Alright, what we're going to do is continue on with simplifying monomial expressions today, but we're going to get into another rule of powers of exponents, a law of exponents, that deals with powers. What do we do with exponents that are raised to a power, or how do powers work when it comes to exponents? So when we get into our prior knowledge piece, all we need to remember is basically the previous laws of exponents. But more in general, we have to recall that when adding or subtracting two numbers, we have to make sure they have the same variable to the same power. But when we're multiplying, we can multiply anything we want, as long as we're following the laws of exponents. So we need to keep that in mind as we're working through. When you add or subtract, same variable, same exponent. When you multiply, you can multiply anything you want as long as you know the laws of exponents. So with prior knowledge, what we're going to do is review the previous laws of exponents. Remembering that when you have any number to the 0 power is 1. Remembering that if you have a negative exponent, what happens? The number stays positive, or it doesn't change the sign. The number doesn't change the sign. It just moves from the top to the bottom, or bottom to the top, and the exponent becomes positive. So there's that law. We need to remember that when we are multiplying two numbers that have the same base, we keep the base, but we add the exponents. And so now we're going to move on to the newest law. So all that is what we need for prior knowledge. And now what happens is, well, does it ever occur that when we raise a power to a power? And the answer is yes, that happens quite frequently. You just have to know how to deal with it. So here's that law, that whenever you raise some number that has an exponent, okay, if you raise that number with an exponent to a power, okay, base to a power, you keep the base and multiply the two exponents. All right, so if you had a number to a power, raise that to a power, keep that base, multiply the exponents. Okay, so you have to know the difference between that and the multiplication rule. So here it is written out using words. If an exponent is raised to a power, keep the base, multiply the exponents. That's that law. So let's put that into practice. We're going to practice that law, and then we'll get into another law when it comes to powers. So here's an example. If we were to simplify this expression, a to the 4th to the 3rd power, well, how does that work? The law of exponents states that when you have a number raised to a power, keep the base, multiply the exponents. So in this case, a to the 4th to the 3rd is a to the 4 times 3. Okay, so it gives us a to the 12th. So that's how that works. Okay, that's what that law looks like. So now what we're going to do is cover a few examples where that law is used, but things may get a little bit more complicated. As you know, by this time, I like to see things get a little bit more complicated. So here's an example. What if we had an expression that looked like this? X to the negative 7, all of that raised to the 3rd power. Okay, so we have this expression, we're going to simplify it. So let's use the law we just now learned. Okay, we just learned the law that states that when you raise a number with an exponent to a power, keep the base, multiply the exponents. So with this example, x to the negative 7 to the 3, you keep the x, but now what you're going to do is multiply the negative 7 times 3. So you keep the base, you multiply the exponents. And when you have negative 7 times 3, you have negative 21. So we have x to the negative 21. So you may think, okay, we're done here, right? And the answer is no. If there's ever a law of exponents you can use, you have to use it. So in this case, we have a law of exponents that we can use because we have a negative 21. We can use the law of negative exponents. So the law states any number raised to a negative exponent is the same thing as 1 over that number to the positive exponent. So that means when we're dealing with x to the negative 21, we have to move that to the bottom and make that exponent positive. So x to the negative 21 is equal to 1 over x to the positive 21. And so we have our simplified expression, 1 over x to the positive 21. Okay, so here's how we begin. We have our expression here, keep the base, multiply the two exponents, and then we have x to the negative 21, use the previous law of exponents on that, and then we have 1 over x to the positive 21. So there's that example. So let's see another law of exponents. So with the other law of exponents that deals with powers, okay, we have a law of exponents that talks about what happens if we have a product to a power. What happens if we take numbers being multiplied together and raise that whole thing to a power? So here's this law. And again, what we talked about previously with the power of parentheses, this comes into play. Okay, so this law states that if you have any two numbers being multiplied or more, two or more numbers being multiplied together, and that whole product is being raised to a power, the law that you can use is that that exponent can then be applied to each of the factors in that product. Okay, so if we have a times b to the nth power, that's a to the nth power times b to the nth power. Because everything that's happening is multiplication. So here are the words for that law. Okay, if the product of two or more bases, okay, because in some cases you're going to see it's more than two. If the product of two or more bases is raised to a power, the exponent can be applied to each base. So that's what the law states. So if the product of two or more bases is raised to a power, the exponent can be applied to each base. Here's our first basic example. If we're going to simplify this expression, we have a product 4 times c, okay, that's being multiplied. We have a product being raised to a power. That exponent can be applied to each base. The exponent in this case can be applied to the 4 and to the c. So let's see how that looks. The law states that we can apply the exponent to each base. So when we have 4 times c raised to the 3rd power, it's saying 4 to the 3rd power times c to the 3rd power. Now what we have to do is consider, can we evaluate 4 to the 3rd power? Yes, we can. 4 to the 3rd power can be evaluated, right? 4 to the 3rd power is 4 times 4 times 4, which is 64. So you can simplify that expression. And that's the law of exponents dealing with a product being raised to a power. So now what we're going to do is a bunch of examples that are going to take into account all of these laws that we've learned so far. All right, so let's get into a few examples. And here's the first one we want to take a look at. Look at this kind of crazy mess that's happening here. 2x squared y to the 4th z to the negative 3rd, all of that raised to the 3rd power. We're going to simplify this expression. All right, so there's many ways that we can do this. In fact, the more complicated things get, the more ways there are to do it. But the first thing we have to notice is that we have this whole thing in parentheses. And this whole thing in parentheses, something's happening to it, it's being raised to the 3rd power. So we can use that law that we just learned, a product to a power, the law that states if I have 2 or more bases being multiplied and I raise that to a power, the exponent can be applied to each base. So what that means is that I can take each of these things, this 2, this x squared, this y to the 4th, this z to the negative 3rd power. I can take each of those things and raise it to the 3rd power. So I can take this 2 and raise it to the 3rd power. I can take the x squared and raise it to the 3rd power. I can take the y to the 4th and raise it to the 3rd power, and I can take the z to the negative 3 and raise it to the 3rd power. Okay, so that's that law in practice. Taking this and applying the exponent to each of those bases. So we have that step done. Now what we need to consider is what now? Is there another law that we can use? And the answer is yes. It's the law we first learned about in this series of notes right now. The law about raising a power to a power. The law that states if you have an exponent raised to a power, you keep the base and multiply the exponents. Okay, so if you're raising an exponent to a power, you keep the base and multiply the exponents. So in this case, we have 2 to the 3rd power. That's going to remain 2 to the 3rd power. In this case, we have x to the 2nd power to the 3rd power. We're raising an exponent to a power. So we keep the base, we keep that x, but we multiply the 2 and the 3. We multiply the 2 powers. Now we have y to the 4th to the 3rd. Keep the base, power to a power, and multiply the exponents. And then z to the negative 3 to the 3. Keep the base, multiply the exponents. Negative 3 times 3. So we have the setup of putting that law into practice. All we have to do now, clean it up. Okay, so we have 2 to the 3rd. We haven't done anything with it. But now we have x to the 6th. 2 times 3 is 6. We have y to the 12th. 4 times 3 is 12. And we have z to the negative 9. Because negative 3 times 3 is negative 9. And so here we are in this stage. So we've taken what we began with all the way down to here, and now we have to ask, are we done? Are there any other laws that we've learned previously that we can apply here? And the answer is yes. We have a negative exponent. So we can use that law that deals with negative exponents. So at this stage in the game, we're ready to use another law that says if we have a number raised to a negative exponent, you put the number onto the denominator and make the exponent positive. So we're doing the same thing with this little piece. Everything else stays the same. 2 to the 3rd stays the same. X to the 6th stays the same. Y to the 12th stays the same. But now that z to the negative 9 moves to the bottom. And that negative 9 becomes a positive 9. Alright, so we've used that previous law. And if you're confused about what just happened from here to here, review the first video in the unit about zero exponents and negative exponents. So you might think we're almost done, and we are, but we can evaluate 2 to the 3rd power. We can evaluate this, so we can do that. 2 times 2 times 2. And 2 times 2 is 8. So we have 8 to the 6th power, 8 times x to the 6th power, y to the 12th power over z to the 9th power. So we've used all those laws of exponents. See, that's how everything comes into play. This is what's fun. So let's review this example. We started with this expression. And we had to use the first law that applies the exponent to each base. Okay, so that's this law. We applied that to each base. Once we had that applied to each base, we now use this law that talks about if you raise a power to a power, keep the base, multiply the powers. Then we had to use the law of negative exponents, and then we evaluated 2 to the 3rd. So we've used a bunch of laws. Let's see another example, because these are kind of fun. So we're going to see another example of using these crazy laws of exponents. And remembering that what's happening with all of these things is just multiplication. We're not adding anything, we're not subtracting anything, we're just multiplying a bunch of numbers. And there are rules to multiplying numbers. Alright, so we have this example. What we want to do is simplify this expression. What laws can be applied? So we learned about the laws today that if you have a product to a power, you can apply each base with that exponent. So we have y to the second power to the fifth power, z to the negative third power to the fifth power. That's that law. The law that states if you have a product raised to a power, you can apply that exponent to each base. Okay, so we have the z to the second power, but it's being raised to the fifth power. Or the y to the second power to the fifth power. Now we have z to the negative third power, but that's being raised to the fifth power. Now what about this y over here? What are we doing with this thing? Well, we have y to the third power to the second power. It's being applied there. And it's just being multiplied. So we have y to the third power, but it's being raised to the second power. So you have to pay attention to parentheses. Each parenthesis is leading us to a different case. And now we use the next law from today that says if you have an exponent raised to a power, keep the base, multiply the exponents. Power to a power. You keep the base, multiply the exponents. So we can apply that to this previous step. We have y squared to the fifth power. I keep that base of y, but I'm multiplying the powers. We have z, negative third power to the fifth power. That means I'm multiplying the powers. And then we have another y, but this time it's to the third power to the second power, which means I'm multiplying those two powers. And so I just clean that up. I have y to the 10th. I have z to the negative 15th. And I have y to the 6th. So when I look at what I'm up to currently, the question is, are there any other laws that I can apply at this point? And the answer is yes. I have two numbers that I'm multiplying that are the same base. What do we do in that case? We have to remember that previous law from other notes. If I have a to the n times a to the n, keep the base, add the exponent. So what I have to do is rearrange this whole thing. I have to rearrange this whole thing so that I can easily see, because all we're doing is multiplying, and then apply that law. Okay, I keep the base of y and add my exponents. I'm sure you're thinking, well, aren't we going to have to do another thing? Yeah, we will. We will. So we clean that up. So we have y to the 10 plus 6 is 16. And then we have z to the negative 15. And so we pause here, and you're looking here. Is there any other laws that we can apply to this? Absolutely. We have that negative exponent. So we can apply the law of negative exponents. The law that states if you have a number raised to a negative power, move that number from the top to the bottom or bottom to the top and make the power positive. So we can take that z to the negative 15, move it to the bottom, and make that 15 positive. So at the top, y to the 16th stays there. The z moves to the bottom, and the exponent becomes positive. So we have our simplified expression. So we have y to the 16th over z to the 15th, the laws of exponents, and we had a lot of them. So let's go back to where we began, this example. This example began like this. We applied all those laws of exponents to get to this. Is it confusing? Yes. Is it tricky? Yes. But is it fun? Absolutely. So we have to remember how the commutative property works. We have to remember that everything is multiplication, and we can apply all those laws. that's the only example for this. I'll be able to walk around and give people help. If you have any questions, email me. But these are the laws and how we can use them. Good luck. We'll continue with more laws later.